Lesson 114, exponential key, which means we're going to be using a calculator. You have three options. Some of you have a calculator, some do not. I'm going to bring out, three different options and show you. Okay, we've got basic, this would be the most basic calculator you can get. Don't have a lot of options on the keys, okay? And so this isn't going to work for what we want to use today. So there's my first one, getting rid of it. My second calculator is a scientific calculator. Some sort of scientific calculator is what you're going to want when we are going to find 1.06 to the 8th power. Now, the slow way would be to do 1.06 times 1.06 times 1.06 times 8 times. Okay, so we could do that even on, I guess you could do that on a basic calculator. That's no fun. That's not what they're teaching us here. So you could do 1.06 times 1.06 and try and keep track of which one you're on. I can't remember. Too hard. So I'm going to, again, get rid of that. Okay, so if you have a calculator, it's kind of like this one. What we're going to do is use this key. This key is the one that takes something to a higher power. It says y to the x. So what I would do is type in, I haven't used this in a while, so just bear with me, 1.06 to the 8 power equals 1.5938481. So I'm going to write that down, and I'm going to do it on two other calculators. One calculator you all have, and I'm going to try and pull it up on my computer. So the answer to that is 1.5. I didn't say how many digits to take it out, but it's kind of good when in doubt to at least go out 3 decimal places. So do you see how it was 593, but the 8 affects the 3. We don't get to just chop off these numbers, so that makes that a 4. So that's the answer. Just so you remember, I did 1.06, then I had this key to the 8 equals. All right, the other option, the fun one that you get to use as you get older, is on the graphing calculator. Okay, I gotta zoom out here. Graphing calculator is going to be needed, Algebra 2 and on up to like pre-calc and calculus. Okay, so I turn it on. I'm gonna erase what I have on there, and I'm gonna show you the keys first. This little caret, a lot of your calculators they call it a caret. This means raising to a power. So I would do 1.06 to the 8. Okay, and then let's see what that looks like here. There it is. Okay, that means 1.06 to the 8th power. Alright, equals. And we get the same answer. Now sometimes I like to use parentheses just in case I'm not sure, so I'm going to put parentheses and raise it to the 8th power. So do you see how I have that? That means the same thing. Enter. Same answer. Okay. So you may not think you have a scientific calculator. These are pretty cheap. I'm thinking like definitely less than 20 bucks. This one was, I don't know, over 100, 115 maybe. But I do recommend getting one at some point, because the more comfortable you get with a graphing calculator, the easier it will be later on. Okay, well, I'm going to also pull up what the computer has. I want you to go to the Start menu if you have a Windows computer. And then mine comes up here because I've used the calculator quite a bit. I'm guessing, let's see, if we don't, go to All Programs, if yours doesn't pop up there. And we are going to look for it. See where yours would be. Accessories. Okay, did you see where I found it under accessories here? And then calculator. Alright, all that means is you can choose, you can change it to view and pick scientific. Alright, and now we have everything you need for scientific to do these problems. Okay, so let's go ahead and try taking 1.06. And you can also type these in the keys on your keyboard. But 1.06, and then I'm looking for the, okay, here we're gonna, mine was y to the x, this one says x to the y, so we're gonna say to the, and do you see it does that caret thing? 8th power equals, and there it is. Okay, so for those of you who don't have a calculator, you actually do have a a scientific calculator on computers. I've never seen a computer that did not have a calculator attached, okay? So coming back to this, I have here read 114 part B, all right? So I'm going to just bring that up on the video. All right. They always use rabbits. We're going to talk about exponential growth, and rabbits can increase their population at quite a quick, rapid speed, exponentially, okay? So, let's say we have Jimmy. He has 150 rabbits. If the number of rabbits doubled every year, he would have 300 rabbits at the end of 1 year, 600 at the end of 2 years, and so forth. Okay, we use this, they say R sub 0. So rabbits at the time of 0. Rabbits at the beginning, to indicate the number of rabbits at the beginning. Then R of 1 means rabbits after a year. Okay, and R of 2 would be after 2 years, 3 years, so forth. So do you see how they do this? It says it doubles. So after the first, in the beginning is 150. Then it says it doubles every year. So then at the end of 1 year, we have 300. Then after 2 years, it's 300 times 2. And then we've got 300 times 2 times 2 and so forth. And you see how it looks here. 2 to the 3rd power, 2 to the 2nd power, because these 2's keep multiplying. So in reality, it's 2 to the however many, see after 3 years, it's 2 to the 3rd power, 150 times 2 to the 3rd power. So after any number of years, it's going to be 150 times t to the, that way you could, let's say after 100 years, we'd figure out what 150 times 2 to the 100 would be, and it's going to be a huge number. But that way you don't have to take this all the way up to 100. That would take you all day. And I know you guys have something better to do. Okay, so here was our equation. This is called an exponential equation. It graphs, remember at the beginning it's 150 years. After 150 rabbits. After 1 year it was 300. After 2 years it was 600. And you see how it skyrockets. Exponential growth starts out relatively manageable, and then it just gets out of control, especially if we're talking about rabbits. I don't know what you would do with all those rabbits. They're going to eat everything and terrorize your neighborhood. So I think who is it, Robert, needs to figure out how to stop that. This is the big thing that we need to know. 2 equations you need to know. A of t equals a sub 0 y, and we're going to look over on this one. Let's say we put $100 in the bank, and I want to know how much money I'll have after 3 years. Okay, $100 in the bank today. In 3 years, it's going to grow, and it's going to grow by this much. So this is 1 plus R. Well, the rate is the bank gets to decide. Let's say it grows by 4%. This would be 0.04. And this number would be 3. Remember, I want to know how much I have after 3 years. So we would put in 100, parentheses, 1 plus 0.04 end your parentheses, to the third power. Okay, and these just are definitions of what all those mean. This is like your ending amount, or this is your starting amount. This is the rate, and you have to change a percent to a decimal. This is the time in years, months, etc. But usually if we're dealing with finances, T is in years, Y is a growth multiplier, and that's usually given to you. Okay. Let's look at example 2 here. The number of bacteria in the dish tripled every month. If there were 2,500 bacteria at first, how many bacteria were there in 10 months? So we're going to use this because this is this is for money. This is for a bacteria type question. So we're going to use, I always write on the right hand side because the tripod's in the way. Okay, A. Okay, we're going to use this. So now we've got to plug in what all they told us, okay? They said that after 10 months, so we want to know, I'm going to write the amount in 10 months equals the amount we started with, 2,500, and it triples every month. So that means that our growth multiplier is 3, and this is how many months, so we're going to check 10. So here is our equation. Okay, now I'm going to go ahead and use the calculator because we get to use the exponential function on our calculator that I just put away. I need to find again. So not ready for today. There it is. Okay. Alright, here we are. Hopefully good, it's focused. So what I'm going to do is first take 3 to the 10th power, then multiply it by 25. Okay, 3 to the 10th power. And then it's going to be a huge number, just so you know, times 2,500. Okay, we had something weird. This, they gave us the answer in scientific notation because it took so many digits, so many bacteria that it's not going to fit on the screen. So what this means is we had 1.4762 times 10 to the 8th bacteria after 10 months. Okay, so bacteria grows at a high rate. All that exponential functions, like I said, increase rapidly. So bacteria is something we do that works with exponential growth. Okay, bacteria, bunnies, and money. Let's see. I'll have to think of some others. Well, let's see what the next question gives us. And the next one's about money. Okay, so you see how we did that? We just leave it like that. What does that really mean? We're 10 to the 8th. Well, this decimal would move 8 times. Okay, so it looks like we would be in the, I don't know, billions, millions, 10 millions, 100 millions, I believe. Million is 10 to the 6th. Anyway, let's move on. James deposited $500 at 7% interest. So these are a lot of important variables they're giving us. Okay. Compounded annually. In next year or the year after, this word will be different. So this really doesn't mean much to you right now. Okay. How much money did he have after? Okay, 14 years is another. So I think we have everything we need. Remember, we have the amount after a certain time is the amount you start with, 1 plus your rate to the t. Okay, so let's plug in the amount we started with, 500, or James started with. Then 1 plus, now 7% is 0.07. 14 years goes in there. Okay, so I could write A of 14. Now what we do is I'm going to simplify these parentheses. 1 plus 0.07 is 1.07. Okay. Now at this point I'm going to go to my calculator and calculate that out. Okay. There we go. So first thing I'm going to do is do 1.07 to the 14th equals times 500. Let's see. All right. So after 14 years, he did nothing, and his money grew. Now, I always like stories like this that math books put in, because I think these were written a long time ago. It's hard to get this kind of interest anymore. And, oh, so it's money. So I have to round this to, dimes and pennies. So we have how much cents? 26 cents or 27 cents? Well, the 7 makes the 6 go up, so it's 27 cents. So now he has $1,289.27 when he started with 500. So that does a nice happy ending to that story. Okay. All right. Let's go to the next example. Use a graphing calculator to graph y equals 1/2 to the x. Okay, this is going to be fun. My graphing calculator. Now, you may or may not have a graphing calculator at your disposal, so if you do, great. If not, just watch the video, and there's not much you can do about it. If we have, or I'll even do the practice with you, because I'm not so... I don't think it's that important that Algebra 1 students need a graphing calculator. So we'll just do these on the video and call it good. Alright, so we need to graph. Turn this on, clear it out. Let me make sure everything's clear. Okay. So here I am. And I want to graph y equals 1/2 to the x. When I do that, I see this is a... Focus is bad here. Go to this button. Again, can't see it very well. There we go. That says y equals. So that's how we graph. Y, I push that, y equals. Okay, and I'm going to graph this, 1/2 to the x. So I'm going to put in parentheses 1 divided by 2. That means 1/2, right? To the, and then I have... This here is where my x is. It says xt anyway. This is your... Alright, so I have that in there. And now I'm going to go to graph. I'm going to see what comes up. Oh, look at that. Beautiful. Okay, so that's all we do. That's all the book is wanting us to do, is be able to graph these things on a calculator and just sketch it. So I could trace, and I will. Okay, when I push trace, that little ball there, trait goes up and down my graph. Do you see that? I like to trace and see where it crosses the y-axis right there. Okay, then I'm going to bring my graph down and around, and there you go. That's all you need. Okay, now in the practice, you're going to do those 3 on your own. This is a 1/3, just so you know. So that's a little harder, because you have to figure out what 1/3 is. You're going to have to mess around with your keystrokes, like what keys do you push first, okay? I'm going to maybe come back to that one. These two, if you don't have a graphing calculator, I'm going to do with you. Y equals 3 to the x, okay? So I'm going to go back to y equals. Alright, I'm going to clear out what we had, and it's 3 to the x. So y equals 3 to the x. Okay, then I'm going to go to my graph, and there it is. It goes through 0, 1 again. I just know because I've done this a lot, and it looks like this, and I'm going to put arrows, okay, because it goes on and on forever. This one, 1/3 to the x. I'm going to go clear this out. 1/3 to to the x, and go to the graph. Okay, and that one comes down. So they're almost the identical. Well, they are the identical graph, just reflected, flipped over the y-axis. Okay, the answer to letter C is probably a financial problem. Yes. So maybe I'm going to do these. I want you to do them. Pause me. I'm going to do them on my calculator. And well, pause me, check it, and then I'll show you how to answer these if you get stuck. I'm not going to use the graphing calculator. I'm going to use what I think you might have at home or the computer. Okay, the computer is going to have the same keystrokes as this guy. Okay, keystrokes means like what do I push in what order. Okay, so I hope you've done these. Turn this back on. Anyway, here we go. 2.5 to the third power. I get 15.625. Okay, not too bad. I think it's just this third one that could throw you off. Okay, the next one is 0.5 to the 0.5. Okay, and we get 0.7071. Okay, all right. This one is a little harder because we can't. All right, this one you might try your way and it's not going to work, or the way I showed you, because you can't do 3.14 to the 1 divided by 3, because what that really did was did 3.14 to the first power, which does nothing. It just means 3.14, right? Divided by 3. So all we did was divide 3.14 by 3, and that's not what we wanted to do. Here's one way to think of it. 1/3, the decimal for 1/3 is 0.3333 with a bar over it, right? So could you say 3.14? This won't give us the exact answer, but it could be closest. So to the 0.33333, I'm going to take it out as much as I can, and we get about, I'll do it on this one, then my graphing calculator will get the actual exact answer. 64343. So I'm going to write that just so we can compare it to the graphing calculator. Okay, the graphing calculator. Yes. What we do is, I like to use parentheses, 3.14 to the parentheses again, 1 divided by 3. So that's going to be more accurate. And we didn't have to round anything by going 0.3333. We actually have 1/3. Okay, so when we do that, we get 1.46434435. Okay, so it looks like our first 3, 4, 5, 6. Okay, this just took it out one more. So they're close, especially if we're going to round to 1.464. Okay. So there you go. The last one, read and answer. I'm going to try and do it really quick. It's probably about money. Okay, Harriet deposited $900. So she put 900 in at 8%, and to the n years. So what we write is, it says first write an equation that expresses where it's going to be after n years. Then find out what it is after 12. So this is what we need to do for the first part. And then this part, we actually calculate 1.08 to the 12, okay? So I'm going to go ahead, do 1.08 to the 12th power times 900, and it looks like she has 2,266.35. There you go. All right, that is the end of this very long video. So I apologize for that, but there's a lot of new stuff. All right, only 6 more lessons that you need to suffer through from me before you get to go to summer break. So enjoy your